I think that's fine. So, hello, I'm Johor, PhD candidate here at the University of Alberta, and I'm going to talk about embedding mechanics generation, my material dial. And, well, let's talk a little bit about mechanics. What are they? So basically, we're going to say that this includes player actions and controls like movement rules, resource gathering, and movement. And for this, sorry to use some image, so some mechanics. And here we're going to specify about 2D platformer view. And we cannot generate the mechanics just in the void. So we need some context in order to use these mechanics. And here, well, we have the flying carpet Mario, which by themselves is nothing, but we need the enemies and the levels in order to test that this mechanic is fun. And this is the important thing that I want you to remember is that for embedding mechanic generation, we have the player. So we have some mechanics in different shapes that can be like this. And to test these mechanics, we need also maps or levels and enemies that will be an obstacle for that mechanic and be tested. And we can then join all of these things so the developer can decide which mechanic is fun and which is not. And well, related to mechanics, we have been doing some work on that. We have a paper related to this and how to Mechanic Maker 2.0, how to generate new mechanics using reinforcement learning agent. And we found some interesting things like here that the agent found like a teleporting Y position and used as a double jump in order to reach the goal. This environment, we took them from Mechanic Miner, from my Cook paper. And then if we talk about enemies, it has been my most recent work has not published yet. But here we took a different approach where we use the enemies and we represent it as a matrix. And then we use the collisions with agents or players that have the mechanic that previously we found, and we just let them interact. And with that, we have a small case study here. So let's imagine that this enemy was randomly generated, and we have our Mario with our basic movements like left, right, and jump. So we will then let them collide with and get some information there, and we can obtain something like this. And you're gonna thinking like, whoa, what does that mean? So yeah, the tiles here, the yellow ones are empty space, the red ones are hazards for the player, and the green ones are the weak point of the enemy. But what happens if we add the double jump of to the player, how this enemy would shape change? And here is one possible option. So now the agent or the player has to do a double jump in order to kill this enemy, but this enemy cannot be killed by the player that doesn't have this double jump. Now let's go to the maps. Here for the maps, previously we have a paper related to using image painting techniques. In this case, we call it leveling painting in order to try to reconstruct some areas of the maps. So with this, the intention is to then generating new maps for these new mechanics, and then we will be able to put it together. And recently, I have been working on generating these new levels data set for from Hollow Knight. So that can be, then would be maybe a small paper and let that the community has something, a new map that I know that for data, it is good for us. And yeah, so again, just the important thing that I feel that this is like a whole way to do it. And yeah, if you find something of this interesting, let me know, any idea. I also want to run a case study when everything is done. So yeah, thank you.